Alright, now let's look at object when it is placed at different position. Okay, so this first case, the object is placed more than 2f, more than 2 times focal length. Yeah, meaning to say the object is from very far, is placed at very far, equivalent to infinity. So you see, for example, a tree. So the ray comes from infinity, reflected by the concave mirror, and we can see the image form on a piece of paper. And we can see that the image is real, inverted, and diminished. Okay, right. So this is similar to the previous one, but we draw ray diagram here, so that is clearer. Yeah? Okay, so the object is placed more than 2f. So remember, the distance from pole to focal point is what we call f. And f is the midpoint of C and P, therefore this is another f. So object is placed here, meaning it is more than 2f. Now u is the object distance, meaning it is the distance between the object and the pole of the mirror. So this is u. This is u, and this u is more than 1f, 2f, right? So this is what I mean. U is more than 2f. Yeah, object is placed more than 2f. So draw ray P reflected towards F, draw ray F reflected parallelly. So you see the two reflected ray, look at the arrow, two reflected ray intersect here. So this is the image. All right, you can draw ray C reflected back the same way it comes from. So you see the three reflected ray intersect at the same point. So the image is formed at the intersection of the reflected rays. All right, so you can see that the image is real because when we put a piece of paper here, like you saw just now, we can see the image on the paper. So this type of image is called real, and it is inverted upside down, yeah? And it is smaller. The size is smaller than the object. So when it's smaller than the object, we say diminish. We will learn more about real image in the next video. Okay, let's look at another case. What if the object is placed at exactly 2f? It is placed at C. Object is at C, the center of curvature. So you see the object is at C. So same method, we draw ray P reflected towards F and ray F reflected parallelly. So you see this time the image is formed at C. The image is formed at C, and the image is real and is also inverted, and this time it is same size as the object. Yeah, same size as the object. All right, so this is when u is equals to 2f. What about if we bring the object nearer to the mirror and place it between f and 2f? This is f, this is another f, so it is between f and 2f. So you can see that the image, we draw the same ray, ray P and ray F. So you can see that the image is formed here, intersection of two reflected ray, and the image is real, inverted again, but this time it is bigger than the object. The size is bigger than the object, so we call it magnified. Okay. Now, if we were to bring the object even nearer to the mirror and place it at F, okay, so same as before, we draw ray P, so mirror reflects it to F, and since the object is at F, we can't draw ray F, so we draw ray C. Okay, so C, the ray passes through C and then touches the object, so it is reflected back the same way it comes from. So now you see these two reflected rays, they are neither converging or diverging, but they are parallel to one another. And we know that image is formed at the intersection of two reflected rays. But in this case, these reflected rays, they do not intersect. They only intersect where? They only intersect at infinity. Therefore, image is formed at infinity, right? Image is formed at infinity. And this type of image is virtual, upright, and highly magnified. All right, the last case, we bring the object nearer so that it is less than f. The object now is less than f, right? U is less than f. So same thing, we draw ray P and we draw ray C. And this time, these two reflected ray, you see, they diverge. They are further and further away. The more you lengthen the reflected ray, you can see that they diverge. They go further and further apart. So, but image is formed at the intersection of two reflected rays. So, how do we find the intersection of these two reflected rays? So, we know that if we were to trace these two reflected rays backwards into the mirror, so they will meet here. But of course, ray cannot go inside the mirror, right? So that's why we draw a dotted line. We draw a dotted line. And they meet inside the mirror, behind the mirror. So the image is formed behind the mirror. All right. So this type of image is called virtual image. And you see that the image is upright. It's not inverted like what we have seen earlier on. So it is upright and it is magnified. Okay. All right. So you see this photo here. This object is a candle and the image is upright and it is bigger. So it's virtual, upright, and magnified. All right. Now we have studied the images of concave mirror, and we see that certain times it is real, certain times it is virtual. So you see the beauty of reflection of light by a concave mirror, right? It depends on the position of the object. So let's look at this photograph here. So you can see the boy is the object. If the object is placed far away from the mirror, in fact it is more than 2f, how is the image of this boy? Look, his image is inverted. Okay, inverted. What about the girl? This is the object, the girl. She is standing near, very near to the mirror. So the object distance is less than f. And look at her image. So beautiful. She is upright and she is enlarged. She's so much bigger and she is upright. She's not inverted like the boy. So you see the beauty of reflection of light by concave mirror. So the image depends on the position of the object. Okay, let's make a summary of what we have learned so far. So we have learned that the characteristic of image of a concave mirror actually changes. It depends on where the object is. All right. So if the object is at infinity, right? So the image that is formed is real, inverted, and diminished. And if the object is more than 2f, which is actually similar to at infinity, when it comes from more than 2f, is considered at infinity. So the image is same as at infinity. So real, inverted, and diminished. Right? As you can see from the ray diagram here. Now, if we bring the object nearer and place it at C, so U is equals to 2f. So the image is still real inverted, but this time it is the same size as the object. Right? It's no more diminished, no more smaller, but same size. And if we bring it even nearer and place it between F and 2F, place it between F and C, that is U is more than F and less than 2F. So the image now is still real, inverted, but the size has become bigger. It is now enlarged. So from here, from these four cases, which actually case number 1 and 2, we combine it into one. So case number 1, 2, and 3, we can make a conclusion saying that all these three cases, they have real and inverted image. And as the object is placed nearer to the mirror, the image becomes bigger, right? When the object distance decreases, the size of the image becomes bigger. Yeah, from diminished to same size to magnified. What about if the object is at F? We place the object at F, U equals to F. So now you see that the two reflected rays, they only meet at infinity. So image is formed at infinity. So this type of image is virtual. And if it is a virtual image, it will be an upright image, right? So virtual, upright, and magnified, because it's now even nearer to the mirror, so it's magnified. And of course, if U is less than F, even nearer, yeah, to the mirror, so it is still virtual, upright, and magnified. So for these last two cases, case number 4 and number 5, the image is virtual, upright, magnified. Okay, we can conclude by saying that image of concave mirror, if it is real, it will always be inverted. Right? They go together. It's a pair. If a real image will always be an inverted image. And a virtual image will always be an upright image. So we borrow the acronym of electromagnetic waves, right? So we take the initial of real R and inverted I. So we take the abbreviation of electromagnetic wave, so IR, IR. And for virtual, so V, and upright is U. So again, we take the abbreviation of UV, yeah? UV. So remember, this helps us to remember. And a real image will always be inverted. Virtual image will always be upright. You will never get a real image but is upright. Neither will you get virtual image but inverted. Okay? Alright, so that's all for today. We will continue with convex lens some other time. Thank you. Bye bye.